Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled a NNML-based route selection approach for optimizing power consumption in IoT-WSN systems. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the research topic area that we have recently designed for IoT wireless sensor networks. So this is basically a routing protocol along with the communication among the sensors to transfer their data from the remote location to the base station. So before starting this video, let's talk about what we will cover into this video. In this video, initially we will discuss about what exactly the application areas in which this can be used. Along with that, the code that we are going to deliver, how we need to execute this code, what files we need to consider, and what are the software requirements for it. Additionally, we will discuss about that what exactly the current problem was in the recent research and what we have proposed in this method. Finally, the experimental outcomes will be shown and will be discussed. So let's start with the video. So application areas. So the communication protocol is for IoT WSN, means wireless sensor network technology. So it is useful in certain domains. You can see the wireless sensor networks can be used for the monitoring purpose, surveillance, forest fire detection, and many other related to the social as well as industrial and many other domains. So this protocol can be used in certain areas, not specifically for the IoT WSN, even for the wireless communication where clustering is important, right? So now let's see that how the code is to be executed. So we will give you the folder which will have the code. These are the files which you need to have, and along with that you must have the MATLAB software with you. As you can see here, we do have the MATLAB software with us. So we are using MATLAB R 2019. You can use 2018, 19, 20 or above, but make sure it should be a full version of your MATLAB. So how you need to run this code? You just need to copy this path, go to the directory where the code is there. You just need to copy it, Control C, and then go to the MATLAB. Here you can just Control V and enter. When you enter, these are the files which are already open. You can see it again. I'm going to some other directory. I'm just Control V, enter, and here all the files those were there in the folder, those can be shown here. Here the files you need to know are, it is a main proposed code, the network that we have designed, and finally the comparison results. So let's see that what exactly we have done. Initially, let's discuss about the base paper that we have considered for it. It was a efficient method to protect the communication and in IoT wireless sensor network. They have developed one of the system in which they are communicating among the nodes by in the clustering hierarchy, along with focusing on the security. So the data transmission is done by using the encryption algorithms such as ECC or something like that. But in the sensor network, the major problem is to preserve the energy. So they have just considered the energy parameter as the communication phase. But not only the energy is the important part. Other than that, there are certain other factors those do affect the system. So what we are doing in this particular scenario, we are using the machine learning in order to select the cluster heads, and then along with that we are finding the route through it, that how the data is to be communicated from the source node to the destination. Here source are the sensors and destination is the sink. So might be you people are aware about that how the communication is done in the wireless sensor networks. It is from nodes to their cluster and cluster to sync. So the technology that we are using here is basically the nodes will be collaboratively form a cluster, out of which the cluster heads will be selected on the different parameters, not only on the basis of the energy. And further, the routing among the cluster heads to send their data to the sink will be done by using the artificial neural network. So here feed forward neural network is used. So the base paper was only considering the cluster selection on the basis of the energy. Other than that, there is nothing highlighted in this particular paper. And finally, the different parameters are considered by them. So let's see with the code what we have done. We have designed one neural system in which the cluster head selection was done by using the three different parameters. It was the distance among the nodes, the energy, residual energy of the node, and the distance with the sink. It gives us a scale rating of 1 to 3, which is useful to select the nodes. So initially we have initialized the parameters that includes the area, nodes, initial energy, the number of the packets, then ETX, transmission energy, reception energy, and many others. All this configuration has been taken from the paper to which we are comparing our things. So you can see here the all the information is given in the base paper. Then tentative clusters are formed along with the tracking the parameters like dead nodes, first node dead, residual energy. Then cluster formation is done by evaluating those parameters. So the parameters are evaluated in the those are basically on the basis of the chances that we need to give to the to being a cluster head. Finally, the communication among the node and the cluster head is done. This is how we have done that. Node calculates its energy with the cluster head, and then on the basis of the energy model, wireless energy model, it is communicating with the nodes, and the energy is getting depleted. The main contribution of this research is basically forming a route from cluster heads to base station. So a route has been developed between the cluster heads by using the artificial intelligence, where it is taking decision. Here net is the object that we have used, which is evaluating these three parameters which I already discussed, that distance, energy, and distance with the sink, to give us a uh, rating. So the route that is having the maximum rating is is used as a cluster route. So if the count of the nodes selected to form a route to the sink is greater than 2, then only a route can be found, else it can directly send the data to the sink, right? On that we have the communication is being done. So the neural network has been done. Feed forward neural network is used into it, where is initial data is generated by us in a manual ways. Even the further modifications are also possible in it. Now let's see that how this code is to be executed. Here, when you are opening this code, here you just need to go to the run, and you just need to click on the button to run. It will execute the number of rounds of the communication and give us the results. So the network is loaded initially, which was in further evaluated to form the route. So the code is running, the results we have already saved to our system, so we can directly compare them. So this is the neural network which is training itself to get the results, and all the communication rounds has been done. So we have just run for the 10 rounds, so you can see this kind of parameters are there. So for 10 rounds, obviously there will be no nodes dead. So let's see if we have run for the more number of rounds, as in the base paper they have run it for more than like, because we have just run it because here they have run for 10 rounds in order to get these results. Let's see how we have compared it. So when we have saved those results to the mat file and compared in terms of dead nodes, alive nodes, remaining energy, half node deads, live node deads, and many others. So these are the results that we have achieved. This is the proposed dead nodes, means our network is getting whole dead in around 1600 rounds. These are the graph of alive nodes. This is the residual energy in every round. This is the when first node is dead, when half nodes are dead, when last node are dead. This is the comparison of the leech, e-leech, which was a base paper, and the proposed. So here you can see the time consumption is very less for individual round. Here The dead nodes graph has been compared for all the algorithms, and the proposed is stable for more time, so it means our proposed system is much better. And finally, all the first node, half node, and last node dead comparison has been conducted, where you can see the first node is almost similar, but the half nodes and the dead nodes are later on, which shows network stability. So further modifications are still possible because here neural network has been applied only for selecting the root among the clustered. Even the clustered selection and the root among the within the cluster can also be modified, and many other modifications can be possible. So to get more information, you can contact us directly. Thanks for watching the video. Thank you.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.